Okay, we are resuming our study for the final on semester 1 of Precalc. And this is a regular Precalc class, not the honors version. And we're at number 17 in the packet. And if you go to the sawtooth kind of function, do you remember how to make tweaks to them? Well, this is a pretty simple one. Which way is that one moving? Be careful. Is it left, right, or up, down? Up, down, and in this case, it's up. So you just take that sawtooth function and move it up one. How do you do that? Well, these dots that make up the vertices of it, I guess you could call them, you just move those dots up one and reconnect the dots. All right, so this dot that was here, I'm going to move up one. And then there used to be a dot down here that moves up one. And then there used to be a dot up here at 1, and it moves up to 2. So when it's all said and done, this one still goes through, no, that goes through 1, so let me see, that goes up the same height, and then down to that. There we go. Whew, harder than you'd think. Okay, so that's the whole thing moved up 1. Now, how about the more complicated kind? Let's focus now on, I know you could make it 3 times taller, or would that make it half as wide? No, it's on the inside, it does the opposite, so it's what? 2 times wider. So you take the width of every point. If that width right now is 1, you move it over, double that. Twice as wide. And so basically the thing gets stretched out left, right. Okay, these kind are the kind I want to talk about though, because everybody has trouble with those. The absolute value, if they do it on the outside versus the inside, you get, of course, 2 different answers. I'm going to start with doing the one where you have the absolute value on the inside. If it's on the inside, that means just the x's are being touched, as opposed to here where the absolute value is on the outside. Then f of x is like y, right? So it's like absolute valuing all the y values. Okay, so I'll start with this one. If I absolute value all my x's, that means wherever I had a negative x, it's going to change. Because absolute valuing the x's, of course, the x's are the left, right, okay? Whereas my x's that were negative, they'd be over here. They have to change. So you remember how this works? All of those disappear, and then what do we do? Don't remember this? You reflect it. Yep. This side here gets reflected across the line. There. So now see how there's a line of symmetry that would run down there? Okay, that's your graph for this one. And when you do absolute value of the y's, that's taking anything that had a y value that was negative, where the y values were negative, it's going to absolute value them, make them positive. So here's the area where y's were negative. So those places all have to disappear, and then again, we do a reflection. In this case, we bounce it up. So this part's gone, this part's gone. My answer is this, that stayed the same, this, and that stayed the same. Okay? So that's the 2 different kind of absolute values. I feel like I could do a better job of explaining that just one more time. Let's say you had this graph. Actually, let's make it go down below here. Okay. And if I wanted to do a do this absolute value to it, would you please draw for me on your iPad? If you have to insert a page, go do it. Draw for me what you think the answer to this would be. You're doing the absolute value of the y's. Don't just draw me the original. Change it so that the y's have been absolute valued. Yep. 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 You moved the whole thing up. Don't want that. Just the stuff that's below the line. and that gets reflected up. Yep. 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 You just kind of moved it up. You have to reflect it up. So this part disappears. You got that right. But then it goes up there. It gets reflected over. Okay. So final answer looks like this in red. Okay. The part that was below the line got bounced up. That's where you take the y's and you make them positive. This is the harder kind, where you go like this. The absolute value lines are around the x. Would you please draw me what you think this should look like now? And I'll give you a quick yes or no. This time, because I'm trying something new, I want to know who has answered and who hasn't answered. I would like you, when you get the answer, to turn it my way and I'll say yes or no. And if I say yes, leave your iPad looking at me. That way I'll know anybody who hasn't turned their iPad towards me, I haven't approved theirs yet. Yours is right, yours is right, yours is right. Keep it my way. Yours is right, yours is right, yours is right, yours is right, yours is right. Kind of depends. Your drawing's a little sketchy, but I think you get the right idea. Yes, yes, yes. Keep it my way so I know who I've checked. Yep, 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 yep. Still waiting for 2 people, 3 people. Mr. E, are you with me? And over against the wall. All right, yup. It needs to be reflected across. And good. Okay, good. Thank you. That was more effective in being able to tell who had answered and who hadn't. The only bad part is, if I do it that way, it's hard for me to tell if I've already checked it or not. You know what I mean? Like, at least everybody's got to turn my way. At least I knew they did it. That's part of the challenge. Is I know you know that when I'm checking people's, I don't know who I've checked and who I didn't. And so I can't always tell if somebody's struggling. All right. So that one's answer for those following along at home was this part gets destroyed because why? Because the absolute value of the x's means negative x's have to go away. And now we just take and reflect this. I explained much more thoroughly when we learned this the first time why that happens. But for right now, I'm just going to tell you, reflect that across there, and there is your final answer. Okay. Now, let's go back to our worksheet, which was in there, and move past it to the next stuff. Now, are there any on this next page, as you look at it, that you would like me to explain? I can do all of them. I don't want to do all of them, but if there's any you need help on, we should focus on those. Yes, sir. All right, I will start 18 for you, but there's only one like it. So when this is the collection of all rectangles, it's just saying you don't know what this rectangle looks like. It could be many different ways to draw it, okay? But it has a length 1 less than 3 times the width. So once again, draw a picture, label it. Here's width. Length is 1 less than 3 times the width. Here's 3 times the width, and then 1 less than that. Make sense? Now I got to go over and make an equation for it. And so it's about the areas of them. So area is length times width. And do I know the area? Well, I know that it's bigger than or equal to 1,000. So I'm going to put the area over here and make it bigger than or equal to 1,000. Now you just have to put in your length and your width. And it says can use a calculator. So that means if I were doing this kind, I would always graph both sides and see where they cross. Okay, so once you get this equation finished by putting these numbers over into it, you'll just graph both sides and see where they cross. All right, so anything from 19, 20, do you need one of these, kind like number 20? Or are those so easy you don't need those? Okay, so I look for the highest degree, it's a 5. So right away I know this thing's going to go opposite directions on its ends. Its lead coefficient is positive, so it's up on the right and down on the left. Then this is what I'd call flyover country. Unless you can factor it, which you would not be able to on that one, it doesn't help you. Then the last thing that helps me is the 2. I know it has to touch at 2 as its y-intercept. So how do I make a graph that goes through that spot, is up on the one side and down on the other? Could it be as simple as this? Yup, it could be. Do I have to be careful and have exactly the right number of loops in it? Nope. They just have to be less than, well, if it's degree 5, it could have as many as 4 turns, but it doesn't have to have 4 turns. I'll give you an example. Here's I equals x squared. Most people know that one, right? It's got 1 turn. Here's y equals x to the 6th. It's only got 1 turn. And yet it's x to the 6th. So you can't tell me you have to have 5 turns if it's degree 6. Could you have 5 turns if it's degree 6? Yeah. This would also be an okay graph for x to the 6th. 1, 2, 3, 4, 5. I think I did that right. 1, 2, 3, 4, 5. No, I did too many. That's a classic mistake, to just make too many little loops. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. There we go. That's also a possible x to the 6th graph. All right. So this could have had a more fancy with more loops in it, but just make sure that I have 2 turns on mine, and that means it could be a degree 3 or 5 or 7 or 9 or whatever. Okay, this one leads with a negative. I hope you know means down on the right, and then you know what the y-intercept is. And remember how to do those? Are you good on that kind now? All right. Yes. Okay. I'm going to clear this quick. All right. So basically, do you get that when you graph something and you see where they cross, those are important spots? Then this isn't just where is this equal to that, because if it was, those would be the answers. But this says where is this bigger than that? Bigger than that means higher than that. So where is P higher than Q? This one is P. The red line is P. The green line is Q. Where is P, the red line, higher than the green line? You're saying from the red line's higher than the green line in that little zone. Would you agree with me that the red line, the P, is higher than the green line in that little zone? And what's that zone from? From what to what? Is that from -3 to 2, or is that from 5 to 10? Yep, it's the x's of it. So it's between -3 and +2. So you would say this is bigger than that between here and here. So for -3 to +2. Does it? It's kind of a tricky one to, like it says, or equal to, so I should include the endpoints. If this hadn't said or equal to, then I would use parentheses. So it's just where is the one graph above the other, and you say the x values from there to there. Okay, let's move on. Further into our worksheet, we're on page 12 out of 23. We're halfway through the packet here. About possible sketches. Do you get how this is different? Because now I know what the roots are. So I have to know that I can't just go, oh, I'm going to go like that. You have to know where it touches. It touches at 2. And it touches at -1 for that one. And it touches at +3. And now you have to go through those dots and then basically do the same thing as before. I know its lead coefficient's positive, so it's going up on the right. It's degree 2 plus 1 makes degree 4. Has to be going also up on the left, and it has to touch all those things. Has to bounce here. Has to bounce at the 2. So cut through, bounce, cut through. There we go. And make sure that you actually bounce where you're supposed to bounce. That one's a bounce, so it should have been bouncing there, and it does. All right, that's an example of that kind. If you can factor it, you should. You've heard me say that before, right? you can factor that one, and therefore you should factor it, and you can get your roots that way. All right, moving on. Got to keep moving. There's just so much in here. Properties. Is it a function? Oh no, tell if its inverse is a function. Ah, that's different. Okay, if something's inverse is a function, then it passes both the vertical line test to be a function in the first place, and then if its inverse is a function, it passes the horizontal line test. Let me show you what I mean. If I make a picture like, let's say this, does that pass the vertical line test? Yes, that graph passes the vertical line test. This is meaning that if I draw a line like this and I move that line, it'll only touch once. Okay, so yes, that passes the vertical line test. So then does it pass the horizontal line test? Here's the horizontal line test. I move the horizontal line this way. Does it pass that? Yes, it does. It only touches once. So that little graph I just made passes both. It's a function, because of the vertical line test, and its inverse is also a function. That's what the horizontal line test does. All right, so now, how do I know what each of these things looks like? Well, they happen to all be things you know what they, like you can tell what the graph is. That's a butterfly that's been shifted 4 to the what? Left. Then you ask yourself, does it pass the vertical and horizontal line tests? All right, this one is a parabola that's got a y-intercept of -1, and it's upwards, so it's like this. Does that pass the vertical line test? Yes. Does it pass a horizontal line test? No. And that tells you that its inverse is not a function. Okay. 24, domains. Oh, huge. Look at how many domain questions there are. The key to domains were there were 2 things that could crash your function. Square roots and denominators. Do you get these 2 things could crash you if it was 3 or 0? Those are things that are not in your domain then. So it's all reals except for, everything works except for 3 doesn't work and 0 doesn't work. Everything else worked. Okay? On this kind, you had to be a little more careful because this has a square root in it and a denominator. Yes, 3 would crash your function, but you also had to take whatever's underneath the square root. Do you remember doing this? And you go 4 minus x squared has to be greater than or equal to 0. That's how you do domains with square roots. You take this and set it. 9 plus 3x has to be greater than or equal to 0, and you solve your little equation. That'll tell you where it's allowed and where it's not. Okay? This one is the kind you can't crash because it doesn't even have a square root that you could make negative, and it doesn't have any denominators to worry about. So you can't crash it, so it's all reals. If you can factor it, you should. All right, I think that's enough on that page. The 2 main kinds are square roots, and again, you set them greater than or equal to 0. And the other kind are denominators, and you say the denominators can't be 0. Okay. The domain's big part. Range. On the range, notice that all the pictures, or all the ones are easy ones to graph. Because we want you to be able to make a little sketch of it for the range, and then be able to tell, based on that little sketch, whether or not the thing, or what the range is for the thing. Do you get that this is an absolute value shape, except it's been shifted somewhere? Where's it been shifted? I'm doing C as in cat. Left 2, so that's like this. Now can you tell me the range of it? It's from how low to how high. And the range then is how low does it go? 0. How high will it go? Infinity. From 0 to infinity then. So once you have a sketch, ranges are easy. Here's another one. It's a parabola. And the parabola has been shifted. That -2 means 2 to the right. That +5 means up 5. There it is. Now you ask yourself, how low does it go? How high does it go? And this one would go from, I think that was 5, to infinity. So your ranges will just be pictures. Unless they are fraction functions, in which case you would find the horizontal asymptotes. Okay, if there had been one in here like this, I'm surprised we don't have that. Let's say 1 over x plus 2. That's a butterfly one. Remember that? And its range, you got to have a picture for it. Butterfly that's been shifted 2 to the left. Here's your normal butterfly, shifted 2 to the left. Okay. And then its range is all about its horizontal asymptotes. Horizontal asymptotes are the ones Bob can tell you. Is this a Bob? Yeah. So it's bigger on the bottom because there's degree 1 on the bottom. And Bob would tell you the y's, the horizontals, and y equals -2 is a horizontal asymptote. So what you'd say is y cannot be -2 for its range. All right, moving on. Increasing and decreasing. If you have a calculator to graph it, it's super simple. But if it doesn't tell you, if it sits on the no calculator part, you just should be able to sketch it yourself. Once I got a sketch of it, no, that's just the butterfly function. Where is it increasing and decreasing? It's decreasing this whole time. So from 0 to infinity, it's decreasing. Here it's decreasing the whole time also. From -infinity until 0. It's a weird thought that a function could always be decreasing, but if you read it from left to right, this function is never going up, it's always going down. All right, extrema. Those are all of the high spots and low spots. If you graph this thing and it's odd, so it might look something like this. It has to touch at 0. Oh, if I can factor it, I should. X comes out, and I got x squared minus 8. All right, that's not going to be real nice roots, but it goes through 0 and then 2 and -2, something like that. It's positive lead coefficient, so it's going up on the right. It must be going down on the left. So I'm going to make it go like that. Okay, so it's something like that. The extrema would be this spot and that spot, the high spots and low spots. And if you're using a calculator, that's second calculate a maximum for this one, or second calculate the minimum for that one. So basically, put it in your calculator. Use your calculator to find the high spot with second calculate maximum, or the low spot, second calculate minimum. All right. Moving on to page 15. Prove if it's odd, even, or neither. Okay, so odd, even, and neither there's a couple rules you're supposed to have memorized. Everybody see if you remember the rule. It has to do with f of -x. What's the rule to prove something's odd versus even? And if you don't know, this is the part where you should take that as notes on the side of your paper at the minimum, and you should review it before the test. There's not many equations that you have to know for Precalc. This is one of them. I'm going to pause for just a second. So, these are the two rules. One's for proving even, one's for proving odd. They both start with negative f of x, or f of -x. What does that mean? That means you should, on this one, put in f of -x, and you see what you get. It's the same equation, except wherever the x was, you put an empty spot, and then you drop in a what? Come on. -x. All right, and now that's supposed to be 2, though. Okay, there. So now we figure out, does this, when I simplify it down, actually equal f of x? If it equals f of x, then you'll know that the thing was even. If this instead works out to be -f of x, then you're figuring out that it's odd. If it doesn't come out to either one, then it's a neither. All right, so let's see what we get when we simplify this. 3 over 1, and that negative, when you square it, goes away, plus x squared. Do you agree that that's identical to the original? So I just proved that f of -x is the same as the original, or f of x. And therefore, we have an even one. Do you get that? Now let's do this other one. I bet it's odd. No, it's not. This one's the only one that could be odd. Let's check and see if it's even or odd. You'll always check even first. F of -x You drop it in, 2 empty spot to the 5th minus empty spot. And what do you drop into the empty spot? A negative x. And then when you simplify it out, you get the negative comes through because to the 5th power, it means it won't cancel. Negative 2x to the 5th. And that's plus x. Does that look identical to this? No. So that means it's not even. 3 dots, therefore, not even. Okay. Now, what if I want to tell if it's odd? Do you remember we factor out the negative 1 from everything? And we see if it works out to be the original inside the parentheses there. So I factor out the negative 1 and I get 2x to the 5th minus x. Now, after factoring a negative 1 out, is this f of x? It is. And therefore, what we just proved is that we did f of negative x was negative x there. F of negative x came out to negative of f of x. And that's the odd rule at action. So we'd say, therefore, odd. Okay? That's a reminder on how to tell if something's even or odd. Basically, you just stick negative x into it. And if it doesn't work out to be the same as x, it's not even. And if you can factor out a negative 1, and it works out perfect to be the original with a negative 1 in front, then you've proved it's odd. Okay. So many things to know. Let's move on to vertex. Find the vertex. Well, if you know where the vertex is, it's so easy. It's just buried right there. And it's negative 4 comma negative 2. The vertex is just that point. So if you can't do it with this point, I'll be really sad. This one, you have to put it into vertex form. Now, to be honest, I have realized that I think the method I've been teaching you to complete the square, it's hard, and I think it's good for you, but there is an easier way to find the vertex than completing the square, especially when you have nasty problems that have a number in front that has to get factored out. So this is not normal, but because I saw results on the test that made me think, you know what, they're not so awesome at completing the square. I better give them this other way. This other way to do it is pretty easy. And it's also valuable to know this little equation. It's x equals negative b over 2a. It comes from the quadratic formula because, you know, it's the same thing as a quadratic formula without the plus and minus square root thing. That tells you the x of your vertex. See, I'm trying to find the vertex, right? So that tells me the x of my vertex. So if I know my answer's going to have negative b over 2a right here. Well, that's pretty easy. What's negative b? Come on. 8 over 2a, which is 2 times the 2, which is 4. So my x of my vertex is just that, negative b over 2a. Also known as 8 over 4, also known as 2. So 2 is the x of my vertex. Now, the y of it is super simple. If I have x is 2, you stick a 2 in wherever you have the x, and you figure out what y has to be. So we go 2 times 2 squared minus 8 times 2 plus 5. I just dropped a 2 into the equation. Now 2 squared is 4. 4 times 2 is 8. 8 minus 16 is negative 8. Negative 8 plus 5 is negative 3. So again, negative b over 2a gives you this. And once you have that number, you can stick it in here and here into your equation, basically. And then solve it, and you get your y of your vertex. The other way I was teaching you is cool and valuable, that completing the square method. But too many people were making mistakes on it on the test. It was like the most missed question. It made me think I should probably just tell you this negative b over 2a part, because that'll probably be easier for you. All right, this one's already in vertex form, so it's piece of cake. What's the vertex? It's there and there. Just have to not say 2 comma negative 15. It's what? Negative 2 comma negative 15. All right, and by the way, the axis of symmetry, that's always just the x of it. So like right here, the axis of symmetry for this one, x equals negative 4. Notice I have to say x equals, otherwise you haven't given an axis of symmetry. If you just said negative 4, I have to mark it wrong. The axis of symmetry needs x equals. So this one, where the vertex was 7 comma 5, the axis of symmetry would be not just 7. X equals 7, yes. Okay, good. All right. And I'm feeling like that is probably as much as I can do and still have you stay with me. So I'm going to stop right there. We will cover page 16, starting 16 through 23. So we have like 7 pages left that we will do on the last day. Okay. All right. That's all of the review I have for you.